Morning. Happy Sunday. All right, we're going to jump into it. This is the client, Stitch client. We're going to start accepting those packets. If you remember from last time, we got the Stitch client so that the Stitch server so that I could accept packets from OBS. We decoded a little bit of the payload so we could look at the timestamp and how large the rest of the packet was. Created a little wrapper for that so we could just capture that whole chunk into bytes mutable. Um, so we wouldn't have to then re-encode the header and the second header in order to send it over the wire. So this time we're going to just take that over from the wire, output it. We're going to try to do that today. The next time, if we have time today, we'll start to make a connection to the RTMP server. We've got a lot of stuff that we could rely on to look at for what we're supposed to be doing there, but we'll see how far we get. All right, the first thing we have, our server starts up. The client also has a server in it. That reminds me, we're just real quick. Let's go look at the server because yeah, I don't like this block on like this. I don't really want this handling so much. I would rather this be renamed like app or something. So let's rename that to app because it's technically the server and the client, and that was just bugging me so much. All right, back to the client. We're gonna do the same thing here. Rename that to app. Oh, then the Starlink updated the dish this morning at about 4 a.m. We'll have to see how it does. Yeah, I'm trying to get the information. Yeah, the version really doesn't mean anything. It's like a UUID. but it's been up for 1600 seconds, 16,000 seconds, pardon me. Everything else looks pretty good. All right, let's get to it. Oops, lost my stats. There we go. So we parse the args, we run the server. Now that the other one's called app, this one can be called server. Listening on a specific address. Hardwire it. Although if we did do packet, we wouldn't have to parse the header in the client again. Although, is that all that hard? Save a little bit of wire size. Oh, do we not have bytes for client? Client, cargo, no bytes. All right, close those. Now we have bytes. Yeah, we'll come back to that. So then we have the loop. We spawn the task. We've got a loop here. Some tracing. These are more info. We've got our stream, our TCP stream. Now the first thing that's coming off of this stream is the size and a U32. Let packet size equals read U32 dot wait question mark boom. Now we could do the same thing, passing bytes into this. I don't think it's going to be as important. So we're going to have this and a timestamp, aren't we? What happened to network? Collect. That's right. We never ended up having a packet. Oh, we do, but it's on the server. I kind of want to use that. So let's move that. This is the second time we're going to move this. We're going to move this over into net. We're going to move this to, actually, let's do a explore. Rename that. Network source packet. There it goes. Let's wire that up in net source lib mod. Oh, come on. All right. It should know what that is now. Tell that to close. Now we have packet available to us as well. Although in server main, where we were using packet, we probably need to import that. Where's net? No more mod packet, yada yada. Okay, back to client. Let's import that. Which also means we need to add net to the cargo.toml file for client. There we go. Oh, hey, did I miss something? Did I ever try Doom Emacs? No, I did not. I did not. I tried Emacs with the Viper. I tried Emacs with Evil, but never Doom. You know what, this TX is going to be something else now. This is going to be packet. Yeah, with capacity, and this needs to be packet size. Almost, that's almost the packet size. Technically, it's size minus 4, not 48, just 4. And in this case, we'll have let time equal to stream.read32 as well. Yeah, send. Let's see, it's an unbound channel. We don't have to do that. Yeah, we'll just get a send error. Yeah, that has time, that has bytes. Stream. Import that. What else? We need that read async read ext on there. Let's see, with capacity. Yes, as U size. All right, now we need to read into this stream dot read buff, read exact. Wait, does this, what does that return? Read exact. We have to await it. It doesn't actually return it here. That needs to be mutable, yes. Should there be a reference to that? Hmm, we have ownership. That's okay. And this might have a sender. If that has a sender going to the channel, that means that this is done. We need to break out of the loop. It's tea time. Gonna pour some tea. Almost there. There we go. Got the lids on. Okay, now we should be able to read the bytes because we got them stuffed into the channel. Good. Now let's set up the client. Let client handle. This needs the RX and the args.connect. Yeah, so T minutes. You need like a Mountain Dew break where you pour it into a fancy glass and talk about bubbles or something. That'd be cool. Let's see, that's still too big. 30? That's a little closer. Okay, I'm going to stuff some of this into a different location. Client, source, server.rs. Take that and that chunk. Well, let's just take all that. We'll get a ton of warnings. It's all right. Going back here, we're going to start up client. Client. Let's get a join handle back. I forget. I'm trying to remember. Trying to remember what the command line arguments were for read chat. Not the command line arguments, the in-app arguments. Read chat. Key bindings. Force redraw. Delete a line. All right. Let's get back to it. Public function. This client. This was going to take the RX mounted receiver with a packet. That'll be a join handle to something. Probably an IO error, IO result. Hey, what's RMTP for you? What's RTMP for you? RTMP is a real-time media protocol. It's streamed to Twitch, like me right now, is using RTMP. Testing. And instead of Twitch, oops, let me make sure I have the right profile. No, wrong profile. Okay. With this profile, you can see that we're going to stream using RTMP, or at least on the RTMP port, to this server. And this will technically be on port 1935, but it'll be using the protocol RTMP. It was developed by Adobe forever ago. And what we're going to do is we're setting up a little bit of a proxy and a delay for our RTMP setup. Having fun with Rust, just chilling. So responding to the right thing. Okay. IO result. Probably fine like that. We'll have a Tokyo spawn, async move, like so. We'll return the result of that. We have to add that into client main, mod server, mod client. Let's clean up main real quick because I can't find server and client. I don't really want to call it server, server, and client, client. Um, and honestly, I don't want to spend too much time on that piece this morning. Let's make that public. All right, how's client, client? Yes, gonna build this up. Standard IO result as IO result. I need to look at the SRT protocol. It's much better, and someday platforms start using it. Yeah, unfortunately, I need it right now. So Twitch uses RTMP, so I use RTMP. I was looking at the SRT protocol, but it's not really going to help me today. I guess I could do SRT locally to Linode and then RTMP out from there. Oops, come on. All right, can't find RX in the scope. Let's fix that. Probably because it's got the underscore. These should really be a little different, but it's okay. Okay, now at this point, we want to loop. We want to start receiving these packets out of the unbounded receiver, and we will send them to a given socket. We have to make this a little bit more involved. Is this project on GitHub? It is not. It's on SourceHut. Let's say git UI. Let's say, is it compiling? Cargo, check. Close enough. We'll take that, that, and that. I'll get you the link in just a moment. Technically, this is it here. Yeah, SourceHut has a little bit more of an old school feel. It's not just for boomers. It's got some good stuff. It's fast. It's got some decent build stuff. All sorts of stuff. Yeah, you're welcome. Good morning, 715209. How are you? What? Sometimes my USB hub has different ideas. All right. Technically, we're going to actually loop forever. We also have to reconnect. Yeah, I'm doing well, thank you. Thank you for asking. Connect to her server, handshake with server. What else? Actually, we need delay as well. Yes, that's right. Am I done with the server? Uh, I think the server's at a state where it is, yeah. Because here, actually, let's do a little roadshow. There we go. Run stitch server. Oh, needs an underscore. I think I need to provide it with a connect. So what this is going to do is this is going to be a super dead simple RTMP server. All it does is accept a connection, start to receive packets, and send them on to something else. What? That was it? It didn't do anything? That was really anticlimactic. It should have at least told us that, hey, you need to provide this. Okay, so when that receives packets, it's going to forward them on to 45454. But we need something listening on 45454. So we'll use netcat for that. And netcat will pipe it to XXD and we'll get the hex dump here. Okay, so now, oh no, come on. There we go. Now, let's find OSB. Oh, OSB, where art thou? There you are. Now, for this, we're going to stream to RTMP on this port, which should be the server. It will then forward it on to netcat and XXD. So we'll start streaming now. Oh, well, I forgot to turn the logging on. Let's try again. Rust log trace. There we go. There we go. Then I think something didn't go right. Let's try again. New connection. Yada yada. Good. And we got the packet that went through. All right. Now, what's important here is that this is actually a message that OBS is trying to send to the other side, to a real RTMP server. And this packet's destined for Twitch. So after our handshake with Twitch is made in the client, it will then send this, and we'll get kind of a kind of proxy going. So at the moment, we're going to close that, pass off OBS. It's like my connection died. It's like, yes, yes, it did. Okay, now at this point where we handshake with the server, we're going to skip all this for now. What we want is just to receive. We want to replace netcat for a minute. So we've got these packets. That, and we need to be able to delay. So what I'm thinking about right now is this delay, right? We know that we have to delay for so long. Pro Theory 8, how have you been? It's been a while. Happy Sunday. Happy Sunday. You wonder if Vim breaks with emojis? Let's try it. I don't think it cares. Yeah, that's just it's Unicode. The one that's always the challenge one though. Blah 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 cookies. Don't care. Okay, and this is actually a rather complicated emoji because it's two emojis with a joiner in the middle. It's the woman emoji and the microscope emoji. Yeah. So Vim can't handle woman scientist. You can see it's got a woman, the microscope, and a joiner, a zero width joiner. What do I think about WebAssembly? I think WebAssembly is great. I look forward to using WebAssembly. Oh, interesting. Did you paste it into chat? Yep, yep. Unicode is hard. Unicode is really hard. Ooh, but you know what? I kind of want to work on the client handshake actually, because once we have the client handshake done, then things kind of start to get real, you know. And what do we do if the client handshake is dropped for whatever reason? You know, I don't think that's going to happen, so let's just ignore that possibility at the moment. I'm gonna I'm gonna code this for my current need. So I think Linode's gonna just be fine, and it's not going to disconnect from Twitch. Duck, the duck. Reference types, bulk memory operations, fixed with SIMD proposals. Oh, interesting. Fixed with SIMD proposals. Hmm. Yeah. let's create another function in here. We'll call it handshake. What is this? This is we need a connection first. TCP socket connect. We need to connect to whatever the address is. Just say it's adder. Wait, boom, that. Okay. Reference types allow you to pass JS objects into WebAssembly. Oh, interesting. Huh. It's basically types by reference. That makes a lot of sense. Gonna handshake the stream dot await question mark boom, and then we start sending stuff to it. Async function handshake. Going to take stream TCP stream, and this will return an IO result. Okay. Now recently we looked at the handshake. We implemented the handshake for the server. And the handshake for the server is fairly straightforward. Handshake on the client is a little bit more tiny. I don't know. It's like identical, just flipped. Oh, that would be neat. Yeah, then it just takes time for it to get everywhere. So another 2 years from now. What project are we doing right now? Great question. Let's see. Do we still have... Here's our Blackboard. We are here. Okay. We've got OBS. OBS is going to be talking to our server. So we have OBS. Then we have server, which is just S. Okay. And then you have Starlink. Starlink in the middle. I am a Starlink beta tester. Better than nothing Starlink. So we have satellite. It goes to something, comes back down. That's not a person. That's the Starlink stand thing. Whatever. And there's a satellite up here, right? You got a little satellite. It's got cool stuff on it. It looks like an alien or something. Who knows? But that's Starlink satellite. It comes down to the little round bubble of a base station. Looks like a little lollipop, and that sends the data on to, well, the next block here. It's actually multiple pieces because I drew it too big. That'll send it to Linode. Okay, and inside of Linode, let's use better rectangles. We're gonna have the client. Here's our client. Okay, so data goes there, comes out here, goes to that thing, goes over this way, out of that into the client in Linode. Adds some sort of artificial delay, like plus 5 seconds delay, right? And then it sends that off to Twitch. And the reason for this is that occasionally we get, uh, little periods of blackout, like boop, satellite's gone, or there's a delay, something like that. It is so small, but it does affect the stream. We're just having fun building these things. Good morning, Classy Cat. Happy Sunday. So we're going to be doing this. And then over here, we've got Twitch. That shouldn't look like that. It should look more like this. Twitch. Twitch is love with an H over there. All right, so we're building these pieces that we're going to highlight with yellow. That's better. Okay, TCP stream. Oh, ping pong. Yes. Will it be possible to at some point to kill JS with WASM? No. All right. Cannot infer the types of the IO result. Return OK for that if everything goes well. Okay, let's build up the client. Handshake. Now, history. I rebooted just a moment ago. Close, close, close. We need to go to page, what is it, 8? Value of, I think, OX03, the value of 3 in it. Blah, 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 blah. Okay. Hold on, looking for it. The diagram's at the end there. Must begin with. The client must wait until S1 has been received before sending C2. Yeah, yeah. All right, so C0 and S0 bits, we're going to send C0. C0 is the value of 3. So we need to send that. Send C0. Write U8. I mean, arguably we could put this all in one packet because C1. Where do we put that in the server? Client server. No, server main. Basically, I want to get the chunk that I generate a bunch of random stuff. Handshake. There. Bytes. No. This one. This is the one I want. I want that. All right. C0. C1. Let's see, and that needs to be 1536 plus 1, so 1537. We'll get to you, fast run. Don't worry, don't worry. Let's see, we need that. Import that. We also need to update our cargo.toml to have fastrand in it. Server, cargo, toml, fastrand, yank, client, cargo, toml, A, B, C, D, F. There. All right, now we have fastrand. And here, those values there aren't correct. We'll get to those in a moment. C0, C1. Using Toki instead of async executor for that project? Yes, yes we are. Yes we are. It's been a while since I've used Tokio. Last time I used Tokio was version 0.2, and I wanted to come back around and play with it. Dev for fun. Good morning and happy Sunday. Curious, what are we using? TCP or RUDP? RUDP. We are using TCP. All right, so we've got this bytes mutable here. We're going to write into it. Let's see, C0, C1 dot put U8. And we have to pass the value OXO3 in. Okay. C0, that is C0. Now for C1, C1 is UDP for streaming not a lot faster? It also introduces the potential of loss, which I'm trying to avoid at the moment. Yeah, there's so much delay in this already. It doesn't matter. It doesn't matter. All right, now for C1, we have to send time, which in this case, epoch for all future chunks. This is going to be 0. C1 time. I think that's a U32, right? 32 bytes. Yep. Put U32 0. Now we put C1 0, which it's the same thing. Is this here? I'm trying to introduce like a 5-second delay that I control instead of Twitch controlling it because I want to have fewer dropped frames. That's actually really high at the moment. Wonder why. Oh, now it's lower. It just didn't like capturing itself. Strange. All right, so then actually that is correct because we just needed to do that so many times and then we send C1, C0. Send C0 and C1. This time it's not. Dev for fun. I recently switched over to Starlink, which cost half as much as my previous internet and is literally 20 times, 25 times as fast. The downside is that I get these little blips. Here, I'll show you the screen. Um, and we're just building software to smooth out this for the stream. So here, it's going to be right there. Now you can see those little drops there. It might not be focused on the camera, but you can see that the lines go up and down. And whenever they go down, we get some lost packets, dropped frames due to network. So we're just building kind of like the RTMP proxy that adds a little bit of a delay so that we can get past those little blips. All right, now in this case here, because we're doing the Rtmp handshake, we're C0, C1, we need to send that. So let's send that. Stream dot, was it write exact? Send exact. Read exact. I thought it was right. Hmm. C0, C1, C0, C1. All of the bytes in there. Thank you. Oh, C0, C1. Wow, that took a while. Which TCP stream am I? We're using this one. That looks good. For happy people. All right. In this case, we've got the whole stream. Now, why can't it find that? Let's check. Because we're trying to find TCP stream. TCP stream is an async write ext, right? Yeah, async write, which then provides that async write ext. Oh, write all? All right, there we go. Now we can import that. We have to await that. There we go. That should be the whole thing. Ah, it's not mutable. There. That should this instead be a mutable reference? Because we're not taking ownership. There we go. Exclusive borrow. All right, so now we have C0 and C1. Okay. The server is then going to respond in kind. All right, where's Firefox? Firefox. So if we go down to the list, we just sent C0, C1. They are going to send S0 and S1. So we should be able to validate, okay, they sent the number 3, there's a time, zeros, etc., with a bunch of random stuff. Now we get that. And when that gets here, then we respond with C2, which has information that they can use to verify that we're doing the handshake correctly. And then they send S2 back and we can verify that they are doing their handshake correctly. It's just This doesn't even need to be bytes mute. Does buff? See, the reason I wanted to use that was buff mute. Oh, nice glasses. Very cool, Cal says Muma. Hold on a sec. Got a question. Just one moment, please. Okay, we're good now. Now in this case, I'm going to be reading that. Ah, I was going to check because I wanted to see if buff, mute, all this stuff is actually written on, it's implemented for foreign types. It is on vectors of U8s. So we could just use a vector here as we're not doing anything else with this bytes mute. It's just a little bit heavy for this. I mean, it's heavier than a vector. So we're going to do the same thing here with capacity. That should have been 1537, shouldn't it? I was a little off on one error that we missed just barely. All right, we're going to do the same thing over here. S0, S1, we're going to read that entirely. So stream, dot, yeah, read exact and write all. Read everything in there. Now we can verify, or off by 2 errors, actually off by 1 errors. Off by 1 errors. Good morning, Museum. So we can read that. We actually have to take some of that and send it back to them. So now that we have that, we send back, wrong file. Okay, C2, 1536 octets long, nearly an echo of S1 and C1. 1537 zeros. Or you use set size and like, because it's that versus unsafe S0 S1 dot set length. See, and this there is like the C program. Now, what's the difference between those two operations? Will this, I mean, we're basically writing to this memory address twice. I see. So we did the same thing here. Yeah, the third arm. It's interesting. A lowercase b. I don't remember seeing this syntax before. But compiler only? Ah, I see. That someday. Will that ever um, get released out further? Oh, allow internal unstable block syntax. Got it. Hmm. That's neat. So that is actually more efficient than with capacity and resize. Could just allocate those 1500 bytes on the stack with an array. True, true. And that is implemented, isn't it? Yeah, and that should be fine. It's not that much. That should still work. Do we have to make this an exclusive like that? That seems weird. The way vacuum works is likely vector view A to. I say. What is? How do you describe this? Like in words? A slice that looks like a slice. Yeah, slice of U8s. Because right now we have an array. Now we need to have something else, which is something else. So if we say this is data, let C0, C1 is equal to, if there's no method no method to be resolved for and self, then it's a simple error. So it needs to be mutable. I see. Okay, so that works. That works there. Hmm. With no allocations. Well, just moving the stack pointer. All right, so then we get down to sending C2. Now C2, come on, stop it. We're going to have to send back the random bytes that came through an S01 and the time that came out of there. Let's see, S0 is going to be S0 S1 dot read U8 and let S1 time is going to be S U32 with the U32 there, and then let S1 data, that one will be S0 S1 dot, so like read the rest of them. Well, I just buff. Oh, I'm doing read, I should be doing get. Name slash end message, yeah. I was wondering that this morning too. Then we have remaining. Could probably just make it automatic. A screen width less than, I don't know, 32. That's true. Yeah, because right now I think it's set to 30 or 35. 30, yeah. So given this, this actually changes the start pointer in S0 S1, doesn't it? So technically, this is the data, isn't it? Like that should be the number of bytes remaining. but it itself needs to be mutable. Yeah. Yeah, given that I went with a little bit less screen real estate for it because some of the lines were really long earlier. That would make it quite a bit more comfortable. No. Oh, now it knows it. See, I'm not certain that the length of the S1 underscore data is going to be correct. Oh, cool. That'd be very useful, Museum. Thank you. Oh, I see. Interactive delete mode is fancy. Yeah. I mean, you could always just not have the interactive delete mode in that case. Because if I went to go delete something, I'd probably come over here. Yeah. All right, so then we have the length. Presuming that's correct, and we could just debug assert it. S1 data length is going to be equal to 1528. There we go. Now sending C2. Now the first time sent by the peer in S1. Okay. So the first thing we do is send C1. Let's C2 equal C2. Data is going to be equal to vector 0. This is 1536 because we do not have the 1 byte at the beginning. That'll be S1 time C2 dot but U32. Now the next one is also a time, but then this one here must contain the timestamp at which the previous packet sent by the peer was read. So we need to have some sort of origin, and then this will increase. So that previous packet when S1 was read. I see. S1 elapsed. We'll make that up. Now, come on. Now when we read that here, let's start that elapsed. Okay, that's the time elapsed. And we need that in millis. Okay, that says milliseconds. Great. Now we need the random echo, which is sending them back the S1 data. C2 dot write all S1 data. Oh, instant. This is going to be the standard one. Sure. Packet, we can write that back out. Then we get our packet back and do some validation. And this was C2. All right, that should be 1536. We need to ensure that, basically the same thing, that this time here was our time that we sent before in C1. I mean, do we really care? All right, so in this case, we read the data. Um, read exact. Mutable. This is going to be S2. Await it for the error. All right, now in this case, if something does go wrong, I'm just going to log it. I don't think we're going to exit. If we could, we do. Yeah, let's go ahead and validate it. All right. Wait, what? Okay. S2 dot read U32 S2 time. This is a get U32. Then let S2 elapsed U32, and then the data S2 random, whatever. That's going to be equal to S2 slash dot dot slash boom. That's going to be equal to 1528, hopefully. Oh, it's saying that the trait bounds weren't valid there because it's exclusive. Getting better at that. It's taking a while. That would have just taken me a while before. Okay, so now we have those. If S2 time is not equal to, that's, I'll redo that, whatever. What is C1 time? Oh, it's going to be 0. That's helpful. Return error. This is going to be standard IO error new, which takes a standard IO error kind. And this one is, it's kind of invalid input or data. Parameters were valid, however, the error is caused by malformed input data. This one. And the error itself will be S2 must match S1, C1, S2 time. Expected 0, receive blah, S2 time. Something like that. Too many? 1, 2. Oh, this needs a format. 3. All right, now the same thing for elapsed is just interesting. Let's just log that. Log debug. Handshake. Let's see, what is this? Ping. We'll do that at the end. Now, one other piece, if, you know, random. S2 random is not equal to, where's C1 data? Oh, it's in CO, C1. 65 bytes in. C0, C1, 65. We don't need the format then. All right, so now we can actually try to run the client and connect to Twitch client. Oh, client cargo. Close that. Try again. Expected 3 arguments, found 2. We're in client main, client, client, client. Really? Oh, we added the delay, that's right. That, and we might actually simulate the delay in here just so that it gives them the right impression. Because we send the data, and then instead of reading right away, where is it? We should probably wait. Where is it? Here. We have to do that before S2. What is this? We need Tokyo time support for this. Client Tokyo. Yes, we have time there. Good. Let's just sleep. All right, that should simulate the delay. So they should know what the delay is during this. Oh, of course. But we also need the delay. Delay, U32, and that's passed in here as well. Delay. Okay. What do we miss? Duration not found. Yes, standard time duration. Right, we could just use put. Clean up some of these real quick. Oh, that's so strange. Yes, it is. And I'm not sure why. Hold on, let me kick it. It says it's currently being used by OBS. Audio. I could put that over there. Huh, there we go. Let me just double check. Yeah, give me a sec. All right, is it back? Should be back. Perfect. Okay. Validate S1. So the data we get from S1, no, just an enter there, please. Thank you. If S0 is not equal to OXO3, we don't support this. Just gonna grab this one here. Colon pound O4X. Boom. That needs to be in a format. That's 0. See, it's over here. Running to OBS, I think it's got some magic, and they must have stepped on each other's toes. All right, and 0 should be 0. S1. All right, I think we can run the client now. Okay. In fact, we're going to do exactly this. I put that in there so it'd be easier for me to test. Uh, Rust log trace cargo run bin stitch client dash dash boom. Yes, we did mean that. Thank you. Let's verify this. I think I like the hyphen better. I really do. Server. All right, there. That'll be better. Also, yeah, they have a number of servers behind that IP. Just pick one. Which one looks? Oh, that one's good. We are going to listen to Surprise Me. We're going to add more to the thumbs up and thumbs down list. And if you like the song or not, give us a thumbs down or thumbs up in the chat. This one's interesting. It's got, what do they call that? Synthar? No, no, it's got that really, really long handle, right? Sitar? This is not stream music. All right, so we've got these elements here. Deregistering event source from Polar. Why? What happened? Did it actually connect? Hmm. All right, your auto tune's leaking through. It's got some beat to it. Reminds me of like a cruise ship. All right, let's keep going. How do we get this to do stuff? Client main. It should have connected because it's not like we do anything. Here we just wait for it. It spawns that. It connects. It does a handshake. We're just not logging anything. Oh, I see. Technically, we should be logging stuff. You know what? Let's get our buddy, Wireshark, out of the closet with you. Okay, we're going to be listening on that with this filter. TCP dot port 1935, thank you. All right. And let's do a TCP dot, it's a DST, not port. Wait, what is he? No, let's just grab one of these. We want to filter this based on the other IP address. So it's IP destination. We want to filter this. Apply as filter, selected, yes. And we chose 92. There. Actually, okay, so that filtered that out. Now we're going to try running the app again. And we'll see if it does a connection. Oh, okay, what do we have here? Let's close IP. Interesting that it didn't recognize this as RTMP. All right, so some error happened. We're not actually getting that out. We need to do something else here. And this one was good for a little bit. Got a little repetitive. Just a moment. There we go. First impressions is good here. I'm going to swap those just for a minute. We should really use like a join on them. Tokyo, join. Guess that's not really what I wanted. I saw that they had either in there. Tokyo, macros. Oh, where'd either go? What was the other way to wait? It was in futures? I thought I saw an async either the other day. I don't remember where I saw it though. I thought it had been inside of Tokyo. I mean, really, I'm looking for like race or something, right? All right, so we just select. What's a different way to do this? Um, this one's a no. Trying to remember, was it in futures? I think futures might have had something. Just double check. Docs on futures. We're looking for basically a, yeah, see they have either here. And that was not inside of futures light. No. What does futures light have in it? Pin ready, stream, okay. Raise. So we could toss in futures light and use raise. And this is on client. We'll probably need it on server too. Hmm. CD client cargo add futures FUTR light server same thing. Go to the foreground. Okay. Now I'm just gonna say raise. We'll give it client handle and server handle. Oh, raise function. I missed it right there. Future raise. Same thing over here. We have listener handle and sender handle. A little bit more descriptive, I think. Okay, Hmm. Could do it that way, or just future. I think I like future better. Future race. Just having, yeah, like that's better. All right, let's do the same thing in main. Okay. Again. Yeah. I think the connection is going to time out. Then it's going to shut down. Let's give it just a couple more seconds. Because we can see that we're connecting, but it's not right. All right, while that's slowly dying, we're going to open up OBS, go to settings, stream. Let's choose Twitch. Sure. And stream key, we'll just enter some gibberish, hit OK. All right, let's go back to Wireshark, stop, reset, continue without saving, that's fine. We do not know what the IP destination is, but I hope we'll be able to tell shortly. Come on, you awake? So I think, ah, what's going on with this? Okay, we're actually capturing too much. We're gonna stop Wireshark. Wireshark is slowly dying. I think it's been buffering a whole bunch of packets this whole time. Goodbye, Wireshark. Oh, you know what? We could just switch it. I have a capture from a while ago. Yeah, it is just being a pill. Does it think that we've got some like window that we need to accept something somewhere? I mean, it probably does, but where is it? Where's the window? I don't see it. All right, we're gonna kill Wireshark. I love this one. This one is the best. Just a moment while I take out Wireshark. All right, Wireshark is gone. We're going to load up one from before. So this is what's supposed to happen. Connecting on port 1935. And we thumbs down this song. I don't know. It just grated on me a little bit. Okay. We connect. What are we sending here? So just part of the ACK, window update, then here. The handshake is supposed to be sent. It's Wi-Fi. Okay. Destination.ip is equal to, that doesn't work, does it? What is the format for this? So you need two equals, no spaces. Used to be destination. Oh, okay. Well, that's simple then. So we just take this, toss this in here, host, boom. We'll just get all the traffic going to there, and we'll try again. Yeah, we get the window update, but nothing happens. All right, guys, I need to take a break for a couple minutes. Give me, I don't know, 5 minutes or so. 6 minutes. Hold on a sec. Oh. Oh, hi. Hold on a sec. All right. Yeah, we're gonna do this. I gotta take a 6 minute break. So we're gonna change this. 6 minutes. And for those 6 minutes, we're going back to the funk channel. I'm back. We're back. Just a minute. All right. Okay. Coming back here. Why? Why is it not connecting to anything? They're not returning anything. Let's just face it. All right. What else? Okay, so why is this client main? Same thing there. We have our channel. We're passing the channel into the client, but we're not doing anything with it yet. We just connect into our handshake. Let's debug some things. Now the screen is black. Thank you, Museum. Testing. Is that going now? I see myself in the preview. Yeah, it looks like it's working now. In the stream preview. Should be okay now. Now, write all should tell us how many bytes were actually written. Ah, C0, C1. This should be C1 underscore data. So we write the whole packet. Otherwise, we're writing whatever the remainder is in that. Oh, you had to refresh. Gotcha. It says there's one error. COC, you're drunk. But yeah, I can see in the bitrate history that it was low. All right, let's try it again. So Wireshark. Oh, borrowed. Borrowed. No. Oh, look at that. And it went away. Lovely. Okay, so did we do this right? Handshake, C0, C1. O3, good. S0, S1, S2. S0, S1, all zeros, S2, zeros plus 5277. Should be the same as ours, 5277, yep. Great. All right, and then it finished. We were done. Okay, now at this point, well, we should have gotten like our time. Why did this not get printed out? Hmm. Our debug. That our logs didn't make it. Well, the one log, right? Log debug, handshake ping, yada yada. I'm guessing it bailed on this, but we didn't see the error. One of these, probably the data. I likely have that wrong. Duration is a fancy debug print format. Why isn't it indenting this? And this. Oh, if let error. You can change the precision. Oh, nice. Hmm, that's cool. Where n is the number of decimal places. One more time. I want to see the error. Yeah, S2 data must match S1 data. Much, much better. Okay, so starting at 64, 65. I thought 0 to 65. Shouldn't that be it? That's what we had before, but I think that we still had an error there. 66, were we off by 2? Or is the length wrong? 5? I think it's 5. Okay, what's S2 random? That's supposed to be the rest of it. So we got 1536. All right, dbg, S2, and dot length. That's the difference. Foo bar is shorter. I did it again. Oh, I'm counting bits for bytes. Bits for bytes. 1, 4, 4, 9, not 65. Lies. Now you know what? We should put our delay. Where's our sleep? We have this after the S sending C2. Oh, that's the wrong spot. It needs to be up here. All right, now we should have a real delay. Either that or they just always say it's 0. Just possible. They just don't even bother to time it. That's how long it took them to process and respond. So, all right, but we show them that we have a delay. Okay, so that should work. Let's get rid of that. Get rid of that. Goodbye, foobar. Oh, I want to try something. Yeah, inline variable. Oh, look at that. Beautiful. Okay, now that we have the client running, we've got the packets coming into the client. We've got the handshake done. Now we need to start sending data. That and then the whole pipeline coming back, which is yet to be done. Connect with the server, handshake, forward on packets. For now, we're just going to do a while let sum packet equals rx dot receive one of these, and then write all. We're going to give it packets buffer. Ah, it's an option. Is it a, yeah. Oh, I see. All right, but now we need an actual RTMP stream going in through this whole thing. So we're gonna have stitch here. We're gonna have the server running someplace, client running someplace else. I'm gonna put the client here. All right, client's gonna run there. Now the server, is this running on 4.5? No, it's running there. All right. And it does the handshake right away. We might need to fix that. It should probably do the handshake after it starts receiving data. All right, this one here is good. Start streaming. Settings. Oh, I switched that earlier. Stream. Custom. R. RTMP colon slash. That one's still alive. That's crazy. I thought Twitch would have dropped us by now. Ah, attempted to subtract with overflow. Client server 36. It should be the packet size. The size here should represent the number of bytes that need to be read and the time. Check server main. Oh, that's parse the header piece here. Oh, we send the packet. +4. So it should always be something +4. And here we're doing -4. All right, what did you receive? I mean, this is really simple. U32, U32, and then the data. I mean, maybe, just maybe, it wasn't the first packet. Because that should tell us how many bytes were actually written. Oh, that doesn't actually give us the number of bytes written. Right, buff will give us the whole size. So we'll writes all of them. Yeah, we just need to know how many bytes this was. Did Starlink have a moment? Yeah, it did. We're working on it. Nothing terrible? Well, I don't want the drops at all. I think we can't avoid the drops entirely. Um, Go to 4, run that. Okay. Start streaming. Oh, it's waiting to build. Ay, ay, ay. Yeah, that's not gonna work. Cancel, cancel. All right, let's try again. You run, you run. Oh, it couldn't connect? And OBS died. All right, close that one. We have 2 and 4. All right, so we'll start 4. Control C that. There's that one. There's this one. Go to OBS. Start streaming. I think this is the right one. 18 bytes sent. That is correct. That's a very reasonable amount for the right size. Panic. Okay, we verified this size. Side. Server line 36. All right, what is the size? All right, one more time. 18. Received 22. Oh, and then a few more. Why? because it read the wrong amount, and it was kind of midstream, picked up some. Okay, this song reminds me of fifth grade. I had this song called the B flat blues. You're going to read exactly this many bytes. I mean, the 4 should have been here. Play it again. All right. Receiving 22 bytes. That's the problem. We didn't resize it. That's why. All right. Again. Oops. Good. And good. Received 22 bytes. Great. And those should have been sent on to Twitch, which I closed Wireshark Drat. We didn't see it. Let's do it again. Because I think at this point they would have responded and had something that we needed to pass all the way back. Okay. Start streaming. It feels like we're missing something. That's not enough. Okay, try again. We'll get the first bits on there too. Continue without saving. Then I think we should actually fix this connection so it doesn't fire up right when it starts, but when it actually gets data to send. Just a minute. All right, so we could pause on this. Hold on. All right. Sorry, I missed some chat. I actually want to wait until these two things happen, and then we can go into the rest of it. Ah, spawn blocking. Have I done much non-Tokyo async? Yes. Yes, I have. We've written a bunch of futures. Futures were cool. Did a bunch of non-async stuff using async executor, um, async standard. I wouldn't say I'm an expert in any of them, just familiar. Oh, that takes a function. No, we don't want to spawn blocking. We actually want something else. Tokyo, task, lock in place. I guess we could just spawn it and await it. That'd work too. So accept is supposed to return two different elements. Ah, brought in TCP listener from standard. No wonder. It should be from Tokyo. This expression has type standard result. Okay. Do we have to unwrap it twice? Yes. One for that, one for the await. Oh, the spawn. All right, well, at least now. All right. That's a bit hacky, but hopefully it works. We could clean that up later. Oh, stream's not found in the scope. Yes. Super zone. All right. Build it again. What? Mismatched types? That should be stream. Hey, I'm Pearl. Good morning. Oh, you were looking around for a Rust RTMP crate recently. This is just to proxy some packets and delay them. So nothing too fancy. Mismatched types. Why? Oh, because now it's just unit comes back. Why is that not IO result unit? Oh, because of that. Yeah, to be able to do RTMP right, I think we would also need an AMF parser, which we're not doing. We're not actually looking deep into the packets. We're only looking at the very outer layer of the packets. Okay, so there's the client. That's the piece that's going to be establishing a connection to Twitch. Now we're going to start the server, which is what we are going to connect to. We're going to have OBS here. Okay, and Wireshark. Let's restart that. So we're going to start connect to our server. It's going to push packets to our client, which is going to connect as a client to Twitch. Start streaming. Okay, so we did our handshake, received some bytes, got sent over to the wire, sent back over to the other, hopefully to Twitch, but we're not seeing it here. Why aren't we seeing it here? Hmm, maybe our settings are wrong? Let's try again. I think this is the host we're connecting to. We really want to be able to filter this out because either that or we use FFmpeg's RTMP server. I think FFmpeg can listen on RTMP. That might be an option. Yeah, that's the same beast. Connection accepted. We're not saying that we connected to the other server. Let's add that. All right. That's more debug. We did get our handshake ping here. Received 22 bytes. These were pretty close together, which is good. And this data should have been sent out to Twitch. I don't think it's getting sent out to Twitch though. Because after we do our handshake, which is that function, come in here. Let's just debug the packet. So we'll know that we received this and that we're trying to send all of those bytes out. Okay, let's stop this one, which automatically stops the other. That's good. Okay, gonna run them again. Actually, that one's gonna fail because it can't connect. That's good. We have to start this one first. All right, now I want to just come back into Wireshark for a minute. Hmm. Now we're just gonna go do the whole thing, filter it out afterwards. Okay, this includes all of our current stream. We're going to filter this out. All right. Oh, come on. Wireshark, behave. It's getting a lot of data right now. All right, we're going to try this. Restart that. Click. Start streaming. Connecting. Got our packets. Forwarding packets. Time. Yada yada. Okay. We can stop now. You can stop. Stop, Wireshark. Stop. All right. It does not seem like I can tell it to stop. Okay. The IP dot adder. It should not be this hard to set this up. 2 equals? Yes. Did it not recognize it as RTMP? That there must have been more that was sent. That debug down. That should have sent. Why would that not send? Then Wireshark is now not happy. Close. Can't stop it. Nope. Wireshark. Oh, we've got a graphic for this. Manage capture filters. Let's see. Really, we do only want TCP. We're going to start there. We're going to filter it like we did before. IP dot adder is going to be equal to that. Should be 0 packets. Great. Okay, now that we have all of those set up, let's run this. Good. Followed by this one. Good. Oh, it already talked. That's not supposed to happen. You're supposed to talk after you have packets. I did set that up wrong, didn't I? Yeah, we moved this and all right, let's move that back. Like so. All right, there's that. What we really wanted to do was not start up the client until there was a packet. So this, we want to wait here until RX has something. Is there something that we can do with Tokyo's, let's say Tokyo, Unbounded receiver. No, not really. I mean, we could call receive on it, but then we'd get something. We'd have some other sort of signal, or we invert this, get a packet, and then fire this up, and then just ignore it in every loop. That'd be kind of gross, but not the worst. 'Cause yeah, we want this up here, but now we don't want to do the connection on every iteration. The other way would be to initial await that only accepts handshake, initiating packets. Yeah, we're trying to figure out when that is, because right now these two things aren't really tied to each other. So is firing up the server so the channel that links them. We could have some other signal, like a one shot. Yeah, we're doing a one-to-one proxy as well. I just did this off. Say, hey, data, go, and that would work. Let's do that. Client main let. You went by the Chokyo chat example? Yeah. Yeah, we're trying to keep as simple. I think a one shot would work here. This is like connected or on connect. Oops, need one of those. Then we will pass in the TX here on connect TX. Maybe we should put that earlier. All right, now the server, when it connects, it will signal. Oh, this is a one-shot sender. Okay. Contains the last value sent. No, we don't want that. We'll use one shot. Then, at this point, we will signal that it can go. All right, now on the other side, we have this here. It's gonna whine about this, isn't it? Like, hey, no, you need on connect like so. And now in here, we wait. We wait until that. It's a future, so we could just await it. Okay, that should delay it, synchronize them. Let's start it again. It should not connect first off. One shot's not a function? Sure. Go back to main. One shot. Channel. Good fetch. All right. Thank you, Museum. Let's give it a go. Give it a M for min width. Oh, interesting. It should change modes automatically. Oh, cool. So we should be able to see that just by switching, just by zooming in on it in TMUX. Nice. Oh, on connect is moving. So client server. All right, let's dash dash M 32. Oh, look, if I start it over there, it's wrapping a little bit. Well, that's interesting. Huh. It actually gives much more space already. Sliding them to the right. Terminals are all different, yes. Still, this is a great improvement. I like it. The names. On connect. Why is that even in a loop? 3 of your terminals did something different, and the fourth did something different too. All right, let's toss a dash D on there. Ah, there it goes. You made 4 different things by that. Wow. Oh, that looks gorgeous. Thank you, Museum. It's a much. That's a very nice improvement. It's very nice. The dash M should be implicit. Should probably have a dash dash compact to force the alt layout. Yeah, that makes sense. Very nice. It's too busy without it. Yeah. I mean, this is so much more comfortable. I mean, we could probably get this like, look, now it's at like 20 and it still works. Except for Bear Cool Cow says Muma. Oh no, no, we just need to shame Bear Duda publicly for having his name too long. Yeah, 21. It's a little much, don't you think? 21. Oh, very nice, Museum. I mean, even like dropping it down, just even that extra 5 pixels gives us so much more room. It's very nice. All right, so it did not connect. That's perfect. Here, now we're connecting, and we're gonna start streaming. Um, let's reset Wireshark. Come on, Wireshark, you can do it. I know. You're holding megs of memory, of data. Come on, Wireshark. It's gonna be one of those days, huh? Goodbye, Wireshark. All right, we want to capture. However, I want to have a better. Now, because sometimes we're going to be the destination.